Okay, I start to record from here. What I was trying to do here is to re-implement mmap, which actually it's available, but it is a non-standard function, I believe. Right. Oh, now it's standard. So that was a bit useless, I guess. Okay, we will see. But anyway, that's not the point. The point is that yesterday I implemented the vector similarity in vector search in order to get similar elements. However, I would like for my bot to also work with product names. For example, a typical snack here in Italy, it's Nutella, and it's also, I believe, well known otherwise in the world, so I will use this example. And if I search for Nutella, I don't have it in this table. I have it because it's very, very well known, but Fiesta, for example, I don't have product names. I mean, if they are not so well known like Nutella, you don't find product names in this thing. But for sure, we have in the much larger database like this one, we have many Fiesta. Let me think something more specific, something like a Kinder Pinguì, which is I will show you. Okay, it's this hyper processed food. Don't eat this shit, but it's very common here in Italy. And I believe I have it here. Kinder Pinguì, that's it. And this is another one in Italian language. Kinder Pinguì, nutritional facts, and so forth. So it's very cool if I can do that. And maybe the file is not so big, it's 1 gigabyte. Maybe it's grep takes a lot of time to do that. But what if I load this file in memory and try to match the items? That could be potentially possible. Otherwise, I could use a vector set in a different way. Let me show you. So there is something called bag of words. The idea is that you have vectors where there are many components, and you set a given component to 1 based on the specific word index. For example, this can be apple. The word apple is at this index. And then we have another word which could be like wood, and this here. Okay, so basically if you want to index a document, you take this should be 0. Okay, you just have one, it's one hot and encoded basically. If you want to index a document, you just check how many occurrences there are of each given word in a document, and then do a weighted sum in the vector. Or you just for example can express this with 0, 10, 5, 3, and so forth. Okay, and then you can normalize the vector. At this point, I could use for full search, for fuzzy full search, because even if you search for a term which is not really there, it will still work, okay? Because if I have a vector, for example, if I have a document where there is apple wood, that will be this one here, and also one here. Now, if I search just for apple or just for wood, this item is going to be reported. The rank it will be reported depends exactly on how many competing items there are, but if a document is strongly about apples, so this is not just one, but it is 5, and this is I don't know, there are because the document was apple apple wood. Of course, there are more interesting algorithms to do this in a more meaningful way, but just to simplify. Then I can use vector similarity for basically to perform full text indexing. But then I thought about one thing. Of course, if I have Fiesta or Pingui, I'm not going to have an index for that. So my idea is, what about combining elements of Bloom filters plus bag of words? So if I have a word, I hash it 5 times, for example. Okay, so I have hash with different salts, like in a Bloom filter. So I have hash 1, hash 2, hash 3, hash 4, 5, modulo vector dimensionality. So each word is going to set multiple items here. Okay, now imagine that you want imagine that two different words completely collide. Okay, just for casually they are the different hashes. Hash 1 is equal to hash 3 and so forth. So there is a collision, but with different ordering, or maybe a half collision. What about if I give different weights to my hashes? Like this is 1 of 1, 1 of 2, 1 of 3, 1/4, 1/5. So basically I'm going to set this to 1, this to 0.2, this to, and so forth, this to 0.5. In this way, when there are overlaps, I have the feeling that we have more information to take things apart. Okay, so of course I still will make my vectors more crowded, but with this technique, still each word has a main feature and less important feature and so forth, in order to distinguish better the signal. At this point, even if with a fixed vector, I can hash Pingui, because it will result in given components there. So that's what I want to do. However, before proceeding, I want to be sure that I cannot do it in a very brute force way, which is with mmap and searching. But I believe that grep is already doing mmap, I guess, and it's extremely slow to do that. This is very likely to take a lot of time. Okay, let's try. Okay, let's this should be enough, I believe. Okay. Oh yeah, I changed the names of this thing. Okay. Other I believe should be null. If other is 0, okay. I want it to select it. Oh, length. I will calculate this with the stat system call. Protection. Flex. Map file. Okay, this is the default. Private. Okay, I will just tell it this one. My file descriptor is my file descriptor, and the offset is 0 from the start of the file. If A is null, error. Okay. Systat.h. This one. File n. Okay, the memory map worked. Now let's do my mem a buff st sides pingu. Let's search for pingu because otherwise it's Unicode and I don't know how to calculate the length in C. I should use libraries and stuff like that. 1, 2, 3, 4, 5. But I believe that pingu is more common. Okay, let's use this. Yeah, it takes a lot. I'm happy with this. One, two, three, four, five. 1, 2, 3. Hola, hola la. There is probably some problem here. small, big len, small len. Okay, let's try something. Let's try if this is actually accessible. No, it's not accessible. If I compile this one, it works. So my mmap is wrong. Let's see what I messed. Read, and it's okay. Map file, map fixed, map private. Okay, now it works actually. It's much faster than grep. Glad I tried. It's a lot faster than grep. And if I try to find something that doesn't actually exist, so it's the worst case. There is some latency, but why grep sucks so much? I understand that it must find the new lines actually, but you know, it's much smarter if there is a single maybe occurrence of the item to try to do a scan of the whole memory to see if the item grepped exists at all, and then find the new line and the line where it starts and where it ends and print it. So even day-to-day tools that we use sometimes are not so smart. But still, there is latency, and if I want to run, this computer is quite fast. If I want to run it at scale, could be more interesting to go this route here, so that with Redis I know I will have sub-millisecond access time for this kind of thing. Certain items may not be very relevant. I have to test this as well. I have to test this. Okay, I will test this in the next episode. Bye bye for now.